Hello everyone, meet Nora, an elderly woman in her mid-60s living alone. Recently, she started having trouble managing the house and started getting quite forgetful, and eventually forgot to take her medications, which unfortunately resulted in her health deteriorating and getting admitted to the hospital. Nora wasn't happy nor comfortable at all in the hospital's busy ward. After some while, she was finally discharged from the hospital and was assigned a personal nurse to give her medications on time. After that, all went well for Nora. However, is that really a solution? As there are not only Nora, but millions of elderly people around the world facing the same problem. So a more practical and convenient solution is needed. And that's what we came up with. Meet BMO, our smart pill dispensing machine.
Now, let's take a closer look at how BMO works. First, the patient removes the lid and starts filling the cylinder with the desired pills. Then, the patient sets his current clock, schedules daily doses, and configures the alarms. Next, they input the temperature limit indicated on the medicine and specify the number of pills. Now we'll have to wait for the arrival of the pill's scheduled time. As you can see, the buzzer sounds and the lights illuminate, signaling it's time for the patient to retrieve their pill. As they reach out their hand, the pill gracefully drops into their palm. Now, what happens if the patient misses his dose? After 5 beeps, if the patient fails to retrieve their pill, an empty message appears on their application, as you'll see now. This MD message indicates a missed dose. Simultaneously, an email is sent to their nurse, keeping them informed about the situation. BMO also monitors the temperature. If the room temperature exceeds the specified limit, a warning message appears alerting the patient. However, once they regulate the temperature, the message disappears, ensuring the medication remains in optimal conditions.
For the breadboard circuit, we use a 5-volt DC adapter with a voltage regulator as our power supply. We connected an LED and a resistor to the lower section of the breadboard to indicate the presence of voltage. And for our project, we're using PIC 16F877A microcontroller. We connected the essential pins, oscillator, ground, VDD, and master clear. And on port A, we have 3 components, parallel LEDs here, LN35 temperature sensor, which is here, and the buzzer. We did not directly connect the buzzer to the microcontroller to protect the microcontroller. We used a open drain connection with a BJT transistor. And to make the circuit simpler, we hardwired those circuits with the voltage divider for the LCD contrast on a circuit board. On port C, we have the signal for the servo motor, and we connected the Bluetooth module to the transmitter and receiver on port C. And on port D, we have the keypad. We had a problem with the keypad, so we fixed it by putting 1K pull-down resistors to the columns of the keypad. And on port B, we have the IR sensor for hand detection, and we connected the LCD bands.